Good afternoon. My name is Matthew Wright. My personal safety commitment is to always wear the proper gloves for the task, and I work at Honda Manufacturing of Alabama.
My name is Brett James. My personal safety commitment is to always wear my safety glasses the proper way, and I also work at Honda Manufacturing of Alabama.
We'd like to welcome you to Gadsden State Community College, and this is our robotics and PLC lab, and today we'll be showing you and explaining to you a little bit about the robots.
So we did a simple little program here. We're going to hit start on it and let it run through it. And basically what it's doing is just showing the accuracy of a robot and the degrees of freedom that one has. At Honda, in my department, diecast, we use robots for a lot of pick and place and palletizing operations. So as you can see right here, this simulates some of the movements that would take place during that.
I work in the frame assembly department, and we use FANUC for sealer on glass. It's very precise. So this here shows that it could get really close, it can hit precise measurements, and the accuracy can be very tip-top. We also use it to install sunroofs, take doors off cars, and many more things.
And now I'll be turning it over to Blaze Adams.
Hey, my name's Blaze Adams. My personal safety commitment is always on my FR and work on equipment. I'm from Resolute Force Products.
My name is Eric Anderson. My personal safety commitment is always use the correct lockout tagout procedures. I'm from Honda Manufacturing of Alabama.
And today I want to talk to you about just our PLC classes and how they kind of influence our work. Right here we have like a basic air compressor PLC program where it has several different interlocks based on comparison blocks. Your overpressure and your underpressure where your compressor cuts on. And this kind of directly relates to me when I go to work. I work mainly in the electrician and instrument mechanic department, and this is something that I do on a daily basis. So it kind of makes it easy to, when I learn PLCs at school, the various classes, the different outtakes we have on it, I can go to work and just relate that directly to work.
All right, now, as you can see here, the PLC is actually an Allen Bradley. It's controlled by about 7 different control cards, digital and analog. I work in engine department at Honda. We use a lot of PLCs and basically everything. It controls everything the robots do, everything from hydraulics, pneumatics, any air pumps, anything like that. So really holds it all together.
Hey, my name's Blaze Adams. My personal safety commitment is to always wear my FR and work on equipment. I'm from Resolute Force Products. And what we have here is a manufacturing line that goes with machine reliability. It's kind of a all-together group of things we've learned with industrial automation, whether it's from trying to keep things reliable, waste management, or all of the different MCs that we've taken. It kind of takes a big span from air to hydraulics to PLCs to basic electrical properties, and it's just kind of an overall look at everything we got. And I'm gonna pass it over to Eric.
All right, yeah, this is the robotics side of it. You can see it's running through the program of it. It's got plenty of different sub-programs it runs through. It took a while to set up, but we got it running. It's really complex. It picks up the blocks, moves them everywhere they need to move, anything that's hard to do by hand or too dangerous. So, all right, and then we'll move on to Eli Greb.
Hello, my name is Eli Gravitt. My personal safety commitment is to always be aware of the machines that I work with. I also work at Honda, and this right here, what we got, it's a pump system. You see them a lot in the industry, especially at Honda. We have tons of them. This one right here specifically, it's a water pump. It rolls through. That's what energizes the motor to turn, and then it kind of releases through the discharge valve. I'm gonna turn it over to Cameron right here. He's gonna talk a little bit about it. He's gonna tell you some more.
My name is Cameron McElroy. My personal safety commitment is always wear the proper eye protection for the job, and I also work at Honda Manufacturing of Alabama. And like Eli said, this is basically a pump system. You see them all the time in the industry. You see them everywhere. Where I'm at specifically in Honda, I'm in the paint department, and we use these all the time in our e-coat and phosphate system to cycle our chemicals through to keep them fresh, and so they don't go stagnant. And so now I'm going to turn it over to Logan Taylor.
Hi, my name is Logan Taylor, and my personal safety commitment is to always wear your earplugs in the plant, and I work at Chronospan. This is the hydraulic trainer we have right here. Basically, what happens is in the reservoir, there's where hydraulic fluid is, and it goes up to this little valve right here. I can turn it on, and hydraulic fluid's flowing through here. It's flowing to the directional control valve. You push it this way, and this cylinder goes forward. It goes in and out through the directional control valve. You push it this way, it retracts, and you can tell all the pressure and the bar and everything and the gauges right here. And
Hey, I want to bring you over to our hydraulic troubleshooting station right here behind the hydraulic instrumentation station. Right here, it's kind of the same aspect. We have, it's just a vast more variety of loads we have. We can go from rotational load to picking up heavy loads, but it kind of just takes the vast majority of what hydraulics can do and how they're used in the field, and allows you to have like a full grasp of what you may encounter at work from what you've taken at school. I'm gonna pass it right back over to Logan.
yeah, this is really just our hydraulic troubleshooting system. There's just a bunch of different components that train you on how to troubleshoot hydraulics when there's a problem with it. And it's just, there's a lot of different parts on here. I'm gonna pass it to Wesley.
My name is Wesley Thornton. My personal safety commitment is to always use the proper tool for the job, and I work at Bridgewater Interiors and Kohler Craft. Right here we have a pneumatic troubleshooting system from Amatrol, and I can show you a little demonstration right here. This is a pickup cylinder right here. The air will turn on and pick up the ball and bring it back over to the designated area. It just uses sensors and air compression and switches and stuff. And we have a lot of other solenoid valves and switches that make all this work. I'll pass it to Savannah.
Hello, I'll be going over the pneumatics instrumentation module. With these modules, we just basically run the air to it, and it goes through the filter and regulator, where we then set the pressure of what we want the air to run through. When you hook it up with these hoses, you're able to determine how you want, whatever you want, the cylinder, or in some cases, you can dismember it and put it on another one. And you can get the motor to run off and on as you please. It really helps a lot when you go into work when they got pneumatic systems at work, and it helps you understand that it's basically worked off of the same way hydraulics worked. Thank you.
I'm gonna take y'all over here to our other building. This is more of our motor control building. It's gonna be our mechanical drives and stuff like that. When we get over here, I'm gonna pass it off to Bailey and Devin, and they're gonna be doing a mechanical drive system. So this is gonna show you a little bit about our other room over here. So pretty much all this right here, this is our motor controls on this side. And then right now I'm gonna pass it over to Bailey and Devin, and they're gonna teach y'all a little bit about mechanical drives.
My name is Devin Chambers. My personal safety commitment is to always wear my seatbelt, and I work at Chronospan.
My name is Bailey Henry, and I work at General Dynamics. Here we are talking about our mechanical drive systems. On this machine, we work with pulley drives, belt drives, and chain drives to help understand how they operate in the industry. We also work with pulley ratios to help determine and work on motors and drives. I'm going to give you a simple demonstration. It uses a variable speed VFD, so you can adjust your speed as you go. You can see how that operates with each pulley drive and such as that. And that's it for the mechanical drive system. Now I'm going to hand the microphone off to Brett James.
Hey, my name is Brett James. My personal safety commitment is to wear my safety glasses the proper way. And this is our motor control station. We've got 208 volt 5-wire source, and I'm going to hand it to Eli and let him tell you a little about some of the components.
Yeah, so this, like Brett said, this is our motor control lab. Pretty much you see a lot of wires going everywhere, and we pretty much just wire this up to make the motor run over there. Talking about each different thing, simply right here, you just got your kind of lights that turn on. Over here, this are your push buttons. That's what starts and stops the motor. Down here, this is your overloads. If the motor ever gets too hot or if the motor gets too fast, anything like that, the overloads will trip and that'll turn off the motor. And like I said, this is just kind of how the motor controls works. We'll run it one time for you if that's what you want to do. So we're going to press the start button right here, and that's going to trigger the motor to come on. And it's going to keep running in that same clockwise position. And then we're going to hit a stop button up here, and that's what makes it stop. So pretty much these contacts right here just pull in, they energize, and then when you stop them, they close, and then they're not energized, and that's how it stops. Well, pretty much that's been all around our labs. We've taught you pretty much about everything we got here, and I hope you all enjoyed it.